Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will demonstrate how to certify a fiber optic link using a fiber OWL optical power meter and a dual OWL series multimode light source. There are 5 main steps in the process of certifying any fiber optic link. These steps are gathering link information and accessories, checking equipment and accessories for proper operation, entering link information into the certification tester if available, and setting an optical reference, also called zeroing, taking insertion loss measurements and storing test results, and then downloading stored test results to a PC and printing a certification test report. Before beginning any fiber test, the user must gather the necessary link information and accessories required to complete the test. Link information is used to help determine how much loss is acceptable for the fiber under test, otherwise known as a link budget. Optical loss measurements are compared to the link budget to determine if the fiber is good or not, which is the same as saying pass or fail. There are 5 key parameters that apply to any fiber optic test. First is the fiber type, which will be either single mode or multimode. In the case of multimode, this could be either 62.5 or 50 micron. Next is fiber length. It is important to know how much fiber is in the link under test in order to determine how much loss is acceptable for that particular length of fiber. Some OWL testers can be used to measure the end-to-end length of the fiber automatically, including the fiber KIT-FO4B-D2xx optical power meter. Otherwise, the user can use jacket markings, installation documents, or other length measurement methods such as OTDR. For best results, avoid estimating the fiber length whenever possible. Third is number of connections. A connection is the point where 2 fiber connectors mate together, such as in a patch panel, wall plate, or mating sleeve. Fourth is the number of splices, which can be either fusion or mechanical. For the purpose of calculating a link budget, most cabling standards do not distinguish between fusion and mechanical splices. Lastly, the user must determine what wavelengths they will test at. For multimode, this is 850 and/or 1300 nanometers, and for single mode, this is 1310 and/or 1550 nanometers. When using a micro OWL or fiber OWL optical power meter, these parameters can be entered directly into the device to calculate the link budget. However, if the link budget needs to be calculated manually, this is done simply by adding together the fiber loss, connection loss, and splice loss. Fiber loss is given in dB per kilometer and varies based on the fiber type and wavelength. To calculate fiber loss, multiply the fiber length in kilometers by the fiber loss. Connection loss is the number of connections multiplied by the dB loss per connection. Splice loss is the number of splices multiplied by the dB loss per splice. Most users will follow the fiber, connection, and splice loss specified in cabling standards, such as the TIA 568. It is also helpful to determine the connector type used in the link under test, which will help determine the right reference cable configuration to use. For accessories, it is highly recommended to keep at least 3 patch cables on hand, since there are 3 reference methods: 1 jumper, 2 jumper, and 3 jumper. Mating sleeves may also be required for some link configurations. Refer to OWL's video on reference methods for more information. Finally, if testing multimode fiber, the launch cable attached to the light source will also need to be wrapped around a mandrel according to cabling standard specifications. Refer to OWL's video on mandrels for more information. Okay, as you can see here, we've gathered our accessories and our equipment that we'll use for this test. In this case, we're using a fiber KIT-FO4B-D2xx optical power meter and a dual OWL multimode light source. Now, you can see that we also have 3 patch cables essentially. We have this straight cable and we have 2 mandrel wrapped cables. Okay, these will be used for zeroing our equipment. This will be used for connecting the power meter into the link under test when we get to that step. Now, first of all, to check the equipment, we have to power the units on. So we press the power button on the fiber OWL and also the power button on the dual OWL. Okay, on the dual OWL, you might not be able to see it here, but the 850 nanometer indicator LED does light by default. Now on the power meter, you will see that an operating mode screen appears with several options. For checking your equipment, we'll just use the simple meter option. So in order to enter simple meter, we press F2 for select. Okay, now you see that the screen says under. What this means is that there's no light coming into the photo detector. As you can see, there's a dust cap on here, so it's not letting any light through. The first thing we need to do is connect our straight reference cable here to check it out first. So we remove the dust cap, and you'll notice that the power reading has changed here. It's reading around 48 or minus 48 dBm. This is normal for measuring ambient room light. So what we first do is connect one end of the straight cable to the detector port on the power meter. Then we take the other side and we plug it into the 850 nanometer port on the light source here. Okay, now you can see that this cable is reading around minus 19.8 dBm. This is actually an acceptable reading for this type of cable. For any multimode reference cable, we want it to read around minus 20 dBm, but that is for a mandrel wrapped cable. Since we're not mandrel wrapped with this cable, we're reading a little bit higher. So, reading a little bit higher with a straight cable like this is okay. So once we've verified that this cable is okay, we simply remove it from the testers and we put the dust caps on. And we will set this cable aside for later use. Now we want to test our reference cables, mandrel wrapped cables that we'll use for the light source. And as you can see, I've taken a duplex cable and wrapped it around a mandrel so that it's a lot easier to handle one mandrel with two cables on it than it is to handle two separate reference cables and two separate mandrels. The reason we need two reference cables is because we have two wavelength ports here. So I will connect these into the light source first. And then we take, let's measure the 850 nanometer first. So we find the 850 nanometer cable and we plug it back into the detector port here. Now, as you can see, it's reading around minus 20.2. Remember, we want to be around minus 20 as far as reference level. Now, this is acceptable. Typically, when you reach around minus 21 or so is when you really want to start looking at replacing your cable. But for our purpose here, minus 20.2 is very good. So what we'll do is assume that that one is good to use. Then we will test the 1300 cable. So we just plug in the other connector here. And notice it says under here. This is because we have not switched our equipment to read at 1300 nanometers. So on the power meter, we simply press F3 twice. So that's reading 1300 nanometers here. And then we also press the wavelength button on the light source. Okay, as you can see, the indicator LED is now lit here. And we have a reading of around minus 19.75. Again, this is very close to minus 20. Okay, even with a mandrel wrapped cable, at least it's, we make sure that it's not below minus 21 dBm. So both of these reference cables here are acceptable for use for loss measurement. And this straight cable is also good, and we can be assured that our equipment is in proper calibration. So once we've checked all our equipment, now it is time to set up the meter and source for the loss measurement. Now that we've checked our equipment and accessories for proper operation, it is time to enter our link information into the optical power meter and zero out the equipment. Now, in order to do that, we need to use the link wizard, but since we're still in simple meter, we have to go back to the operating mode screen, which we can do by pressing done, and then hitting F1 to highlight certification meter, and then press F2 to select. Now, at the start menu screen here, you see that option 1 is the link wizard, which is what we need to do. So we press the number 1. Now, you'll see a screen come up that says select link. Now, as far as the fibril is concerned, a link is simply a group of fibers that have identical characteristics. So the same number of connections, same number of splices, same fiber type, same fiber length. And in the fibril, there are actually 8 different link configurations that you can store. But what we're going to do is we're just going to select fiber link number 1. And we can do that by pressing F2 to select. Okay, here you see the link name. This is a way to conveniently name the link that you're testing that day. It'll come out on the report, make the report more meaningful. But for our purpose today, we're just going to leave it at the default value and press done when we're done entering. The next screen asks us to put in the date of test. Now you can see the format of the date of test here with 2-digit month, day, and year. And notice there are slashes in between. We need to make sure that when we enter our date, we enter some special characters. Special characters are located under the 0 key here. So what I'm going to do is I'm going to enter the date today. So 03, I'm going to put a dash in. It's just as good as putting a slash in. And then we're going to put in 2, 1, 1, 3. Okay, there you see we've entered our date. So once we've done that, we press the done key. The next question that we're asked to answer is fiber standards. Now there are quite a few different cabling standards in the industry today. Most of the time you will use the TIA 568, although there are other standards like this ISO standard, which is used in Europe. There are some Ethernet standards, and even if you're an advanced user, you can develop your own TIA type link budget, TIA type standard by configuring a user definable standard. But for our purpose today, what we're going to do is we're just going to select the TIA 568. So we press F2 to select. Now we have to pick our fiber type. In this case, what we're going to do is we're going to test a 62.5 micron multimode fiber. So if necessary, make sure that that fiber type is highlighted and then press F2 to select. The next screen asks for the fiber length method. Basically, it's asking you to enter the length. There are 2 ways of doing this. You can either enter the length manually. So if you know the length already, you can just type it in. It's quite easy to do that. However, if you do not know the length of the cable, you can use the meter to measure the length, this meter right here. Now notice that there are 2 ports here. There's a detector, which is a receiver port, and this port is used for the transmission or the transmit port in the fiber optic length test. So what we're going to do is we're going to assume that we don't know the length, and we're going to use the meter to do that. So press 1 to use the meter. Okay, and then the next screen here kind of describes how you're supposed to connect the tester in to the link in order to take the length measurement. Now, as you can see, you need fiber A and fiber B, a fiber pair required. So you need 2 fibers plugged into your link. And what we're going to do here is we're just going to use the duplex cable that we have here. Use this as part of the fibril. We're going to plug those in. So now we have a cable attached to the transmit port and the receive port. Here, let me move this down so we can see better. And what I've done here is I have a simulated fiber optic link. Now you have to use your imagination. We have a side B and a side A. So what we're going to do is we'll use 2 fibers out of this link, as it says here. It says a fiber pair required. So what we're going to do, let's use ports 1 and 2 for this length measurement. It doesn't matter which ports you use because they're all in the same link, same cable, so they all have the same length. So but what we're just going to do is use fiber number 2. Or I'm sorry, ports 1 and 2. But at the far end, obviously we need to have a loop back. That's what this says here, patch fiber A to fiber B at the far end of the link. So we take our 3rd patch cable and we connect it to ports 1 and 2 on the other side. Okay, now as you can see, we have a loop. Goes from fiber 1 all the way through the loop into fiber 1 here, comes around this loop and comes back on the receive fiber into this port here. So once we've connected in, we simply press F1 for done. And as you can see, we have a fiber length. Now, this link is very short, so it doesn't register as being very long at all. In most cases, you'll have a length number shown up here. Let's say, for example, 100 meters. So it'll say the number 100 right here. When the length is entered in this field here, we simply press done to accept the value. And then we review here where it says enter fiber length, and it'll have our length measurement in here. Now, coincidentally, this is where you would have gone if you were entering the length in manually. So what we're going to do is we're just going to press, we're going to assume that the length is 100 meters, but let's actually say that's 325 feet. We want to enter it in feet. So we simply press F2 to toggle back and forth, as you can see. So let's just enter 325 feet, and then we hit done when we're done entering the length. Okay, now once we have done entering the length, we no longer need the patch cables attached to the link or the testers. So we disconnect the patch cable from this from both sides. Okay, we take all the cables. We don't need these anymore, so we're just going to bring the patch cables back to where they need to be. In fact, we can plug in these cables back into our light source. And it's always a good practice to keep dust caps on the patch cables whenever possible. All right, so now what we're going to do is we're going to go on to the next step where it says inline connections. Now, a connection is simply a patch panel or a wall plate or a mating sleeve. So, for example, in this configuration, this simulated fiber link, this bulkhead right here, where you would plug in a fiber patch cable, is actually fiber behind this. The connection between the two is what you need to answer here. So this is one connection, and this is two connections. So in this fiber link right here, we have two connections, one on this side, one on this side. Okay, so in our link wizard, we're going to enter the number 2 simply because we have two connections. Okay, now the next question is the number of splices in the link. Now, usually in multimode fiber, there are no splices. That's typically not something that's done. However, with newer type of connectors such as Unicam or other no polish, no epoxy type connectors, there is actually a little mechanical splice produced inside the ferrule during the termination process. So it is okay if you want to enter in a splice for each side. So again, taking our example here, let's say these fibers right here have a Unicam on them, and these fibers have a Unicam on them. So we have a splice and a splice. So that means we have two splices. So what we'll do is we'll assume we have two splices here. And then we'll hit done. And that's all the information we need to enter in. Here is a review of what we've entered. So the standard, the length, the connections, splices, fiber type. And if any of this information is incorrect, we simply hit no to re-enter the information. But since it is correct, we're going to press F1 for yes. Now you can see that we are up to the set source references screen. This is simply another way of saying zeroing out the equipment. Okay, so what we're going to do, most people want to start at 850, so we're going to press F1 to move the asterisk, as you can see here, in front of 850 nanometers. Okay, what we're going to do is we're going to set a reference or zero out 850 nanometers first. So what we need to do here is find the 850 nanometer reference cable, and we plug it into the detector port and make sure that we have our cables plugged in here. So once we have our connection, we simply press F2 to set. And we have a screen here that says connect 850 nanometer source. The source must be in continuous wave or CW mode, An LED must not be blinking. The LED it's referring to here is the indicator LED. Now, you might not be able to see it real well, but the 1300 wavelength is actually selected right now. So we have to switch the wavelength with the lambda key. Now, when you're switching wavelength with the dual owl, you'll notice that the indicator LED does flash briefly, but then it goes solid again, goes continuous. We have to wait till it's continuous before we continue here. So now that it is continuous, we can press F1 for done. And then just a review saying, are you sure you want to set the reference? And we do, so we'll press F1 to confirm. Save the reference, and now you can see that our reference level is minus 19.90 dBm. Okay, this is very good. Remember, we want to be roughly minus 20. This is very close. Now, since we're doing a 2 wavelength test, we got to set the wavelength to 1300. If you do want to store at 1 wavelength, you can do that, and you would simply press done. However, since we do want to test both wavelengths, we're going to press F1 to switch the wavelength. Now the asterisk is in front of 1300. And then we simply hit set again. But now it's saying connect the 1300 nanometer source. So what we have to do is disconnect from the power meter. Take the 1300 nanometer reference cable and plug it into the detector port. And then we also have to make sure that we switch over to the 1300 wavelength here by pressing the lambda key. Again, wait for it to stop blinking, then press done. And then F1 again to confirm. Now we can see minus 19.87. That's also very close to minus 20. So what we can say is that we've zeroed out our equipment correctly. We have good reference values. We've entered all of our link information in, so now we're ready to take readings. So in order to do that, we simply press done to exit the zeroing screen, and then we begin taking readings here and press F1. Okay, now just to cover a little bit about the screen before we continue on. Notice that we have some information here on the screen. This is basically what the screen will look like when you're taking measurements. You'll have the big number over here is your loss reading, and notice it's a loss reading because you see dB here. dB is loss. It'll say pass, and it'll say pass by a certain amount. So this certain amount here is your overhead. And I will argue that overhead is more important than loss, because overhead tells you how close you are to failing. You see we have our fiber link name here, and we have our fiber ID here. It says new name right now because we haven't stored any data yet. Now on the right hand side, we see we also have 79 degrees. That's our temperature, our battery life, and we have our wavelength here. Okay. Now as you can see, our indicator LED is still on 1300, but our power meter is set to 850, which is why this reading is not correct here. So what we'll do is we'll switch our wavelengths back to 850, okay? And then we will connect our 850 nanometer patch cable back in. And as you can see, we're very close to zero. What this does is verifies that we indeed have zeroed our equipment. Now, it's also a good idea to check your 1300, so we're going to reconnect back into the 1300 patch cable. And then switch the wavelength on the power meter, and then switch the wavelength on the light source. And you can see, again, it says 0.00. So now what we've done is made sure that our equipment is properly zeroed. Once we've done that, now we can take the units to opposite ends of the link and start taking readings. Okay, now that we have checked our equipment, we have zeroed our equipment, we've entered all our link information, now it's time to take readings on the fiber link. Now, as you can see, we're still connected in as if we were checking our reference. So what we have to do is disconnect the patch cable from the power meter. And the dust cap. And what we need to do is we need to take both units to opposite ends of the link. And what we'll do is we'll do that here. So we'll take the light source to its side. We'll take the power meter with its reference cable to the other side, and then we'll again use our simulated fiber link here. As you can see, side A, side B. So this could be a different closet. You know, this could be one closet, and side B could be in another closet. The first thing we need to do is make sure that we plug into port 1. Typically, we're going to start at port 1 and then move on until we're done with all the fibers in that particular link. So what we're going to do is we're going to do that now. We're going to plug into port number 1. All right, now we plug the light source in the port 1. But what we're going to do, actually, most people will store 850 nanometers first. So let's switch the wavelengths to 850 on this side, and then again on 850 on this side, making sure that the indicator LED is solid. We want to be taking measurements in continuous wave. So what we do is we take the light source and plug it into its side. So we find the 850 nanometer cable and we plug it in. Okay, as you can see, we have a loss reading on the screen once we plug in. Now, as a helpful tip, when using the fiber-OWL and dual-OWL together, since we have a cable for each port, it's easier to test all the ports, 1 through 6 in this case, test all those ports first at one wavelength, and then switch the wavelength one time to 1300 and then take the readings at 1300. It's a lot easier than disconnecting and reconnecting every time and switching the wavelengths every time. It also ensures that the fiber numbers maintain their sequence. So first of all, what we're going to do is we're going to look at our reading. It says pass, so we're okay with this reading. What we'll do is we store the reading. Now, the first reading that you store will ask you this question here. So enter fiber name. Now, this fiber name is simply a prefix to a port number that the fiber-OWL will automatically append to the end. As you can see, our default value is FBR:, but you could change this name to make it more meaningful on the report. What I'm going to do today is simply take the default. I'm going to press done because I'm done entering. And as you can see, all the information about our reading is here. So our fiber link number, or I'm sorry, fiber link ID, our fiber number, so fiber FBR:1 for port number 1, our fiber type, and our loss reading, and our pass reading, and our wavelength. So once we've got this information on the screen, we're happy with the result. We simply press F3 for save. Okay, now what we need to do is connect into fiber number 2. Notice that it's showing you fiber number 2 here. So it's ready to take a reading for port number 2. So we simply disconnect and reconnect to port number 2 on this side. Port number 2 on that side. As you can see, we have another loss reading here. So we're happy with this result. It's passing. We simply press F2. And here's our review screen. We simply press F3 again. Now, as you can see, you can store all the readings this way. So what I'm going to do is I'm just going to speed the process up, and I'm going to store all 6 fibers in sequence here. Now, we've stored all the readings for all 6 fibers in this fiber link, but now we need to test at 1300. We will still use the same test cable over here, so we just plug the power meter cable back into port number 1. But now we take the 1300 nanometer patch cable and plug it into port number 1. Now, as you can see, it says under here, and that is because we're set to 850 here, but we have we still have the 850 nanometer LED lit. We need the 1300 lit. So what we need to do is change to 1300 on both sides. So on the light source, you can see make sure it's not blinking anymore. And then you can see there's a reading here. Of course, we're still set at 850, so we need to press F3 to switch to 1300. You can see now we have another pass reading. What you will also see is that the fiber number got reset to port number 1. FiberOwl does this as a convenience, because to make sure that all of the fibers maintain their sequence. So we're starting at fiber number 1, and again we just do our store and save. What I'm going to do is I'm going to just do that for all the fibers. So now what we've done is we've stored all of our readings at 850 and 1300. We know that there are a couple 1300 readings that failed, so we need to troubleshoot and find out what's wrong with those cables. But what we've done is we've had all our readings stored. Now we take our readings and download them to a PC for a report. Once data has been stored in the optical power meter, test results can be downloaded to a PC to produce a certification test report. First, install the USB driver and OWL Reporter software from the supplied CD or a USB flash drive. Connect the power meter to the PC using the supplied USB cable. And then power on the power meter. Then start the OWL Reporter program. The program shortcut can be found in the Start menu. When the software has started, the screen will initially say no data loaded as shown here. Download the test results to the PC by pressing either the download menu option or the download button. While downloading, the status bar will say searching for OWL device. Once the test results have successfully been downloaded, the data will appear in the OWL Reporter screen. The test results can be viewed in 2 different formats. This view is called Circuit Detail View. It shows detailed information about a single fiber run. The other view is called Circuit Summary View. Circuit Summary View shows basic information about a group of related fiber runs. Certain buttons become active when Summary View is selected. Pass-Fail, Overhead, which shows how close the test is to its fail point, or Optical Loss. Toggle between Summary and Detail View by pressing this arrow button. Test results can be printed from the File menu or Printer button. The printout will show test results based on the currently selected view. The reports are formatted to look like the OWL Reporter screen. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos, or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.